Next up, I'd like to introduce David Lawrence, who will be presenting delegations. David is a software engineering architect at Salesforce and is coming to us today from Northern Vermont. It's David's second time presenting at NANOG. David's first talk at NANOG was for the IETF status update and encrypted DNS at NANOG 77 in Austin in October 19th. Welcome, David.
Am I on yet? Oh, there we are. How do you do, fellow kids? So as mentioned, I am David Lawrence. Many of you will have heard mention of Tail. That is also me, if you come across that. Tigger, it's good to see that you've made it in attendance today. I was told to say hi, so hello, Tigger. I am here to talk to you a little bit about the DNS. Now, most of you are already familiar with the way that iterative recursion works on the DNS, right? That you have to first ask the root servers about a name you're interested in. They will give you a delegation, in this example, down to the UK name servers. They will tell you, oh, you want to go talk to these other name servers who will give you information about co.uk, and finally you can get your answers for example.co.uk. But as the classic example of iteration shows, it is just turtles all the way down. All you have is the name of the next name server you're supposed to talk to, so all you really know about it is that you're expecting it to answer for you on UDP port 53. Well, what if we could change the way that stack of turtles worked? That one of the turtles could tell you, oh, you know what? The next name server I want you to talk to is not actually a turtle, it's a tiger. And so this is how the things might change. Well, we have a way to do that. It's called the deleg record. This is being deployed to software all around the world right now. Let me know how it goes for you, and thank you for coming to my TED Talk. Little secret is this doesn't actually exist yet. So first I want to clarify something about metaphor. I don't like the turtle versus tiger thing. I know I'm kind of in a hostile environment right now in that operators say it's always the DNS, except when it's actually BGP. But I will point out that it has been 40 years now that the DNS has been a very successful technology on the internet, and it's used every day in millions of ways. It is highly resilient. It is one of the most successful protocols that we've deployed apart from IPv4 itself. However, suggesting that was a cockroach also was not as great. I will also observe that why I started with the cringy old guy joke is also directly related to we've been doing delegations the same way on the internet for the same 40 years of using domain names. So what we're talking about now is a different approach to doing that. You're all familiar with the old way. We want to work on this new way. So here's how we came up with this proposal for delegations. A fellow by the name of Petr Spacek from ISC wanted to get us together to talk about all the difficulties that we have with the DNS protocol, things that DNS operators want to see and developers want to see improved in the way that the DNS works. And so if you could change things about the DNS, what would you change? And one of the things that we realized was that in order to efficiently scale that, if we were going to approach our big, hairy, audacious goals, that we needed to have something that would be a low friction way to switch into the new way of doing things. And significantly, it couldn't really break anything with the existing DNS. Were a few possible ways. Those of you who are familiar with the DNS might know something called eDNS, which allows things like bigger packet sizes and negotiating certain options. There are also specially scoped names that you may have seen, like SRV records, that let you look up, where your Minecraft server is on the network. So maybe we could use one of the existing methods of doing this. Well, it turned out that Tim April from Akamai had come up with a proposal right in the start of the pandemic that unfortunately did not get much traction because pandemic, and it was modeled on the service binding record, which you may have heard Jeff Houston mention in his talk about trends in IPv4 and IPv6 yesterday. The service binding record was actually just standardized, finally standardized as an RFC by the IETF in November of this past year. And so we wanted to leverage the semantics of how that service binding record worked, except put it in the parent, so that when you got a delegation back, not only would you get the old style name servers that would let the legacy DNS network work, but you would also get these additional deleg records that would suggest, oh, so you're a modern enough resolver to understand what this is. Please change to this other method of using more modern name server resolution. And so here's what a sample response might look like. I want to emphasize again, this doesn't actually exist yet. This is just one of the starting straw man proposals for how to achieve what we're trying to achieve. The key things about what we are trying to achieve and build into this is this opportunistic discovery idea, so that when you ask for a name, currently, some of you may or may not be aware, there's a couple of different ways of resolving names, one of which is the standard, you just always throw out the full name that you want resolved. The other is called QName minimization. But either way, you discover the NS records, and we wanted at the same places where NS records would be returned, that this record would be returned as well, and would seamlessly switch to it. It needed to be transparent to legacy resolvers. That is, that if a legacy resolver encountered this information, it wasn't going to fall over and die. The service binding aspect is this key value pair extensibility, where we could define some behaviors that we want now, but then look forward to a future in which we could identify additional mechanisms that we might want to extend the record with. Significantly, we also want to be a parent-side only record. That is, you couldn't, one of the existing problems that we find in the DNS operators community is that NS records living in both the parent and the child get out of sync and make things like DNSSEC very confusing. We also, in order to achieve deployability, we wanted to make it that we weren't putting in a raft of additional requirements on the people that run the authoritative name servers, particularly the ones at the TLDs like .com or .uk, that would make it even harder to get them to adopt this and roll it out. So there is no special processing for the general idea of this record. There is no, if this record is in the zone, all the authority really has to be told is serve it in the same way that you would serve an NS record. You don't have to be told, oh, and do these additional special things. This particular proposal that we have also has this nice feature where we could extend the role of the network operator, the DNS operator in the DNS space. Those of you who are familiar with ICANN might be familiar with the registry, registrar, registrant model. One problem with that model is there's no observed role for the DNS operator explicitly in that, because it was based on the 30 years ago when the registrant and the operator tended to be the same people. And so one of the big things that's created a problem with is that DNSSEC, if an operator wants to provide full service end-to-end DNSSEC signing of zones, they are still reliant on the client, the registrant, interacting with their registrar in order to get updated cryptographic information into the zone, and this has been a pain point in the deployment of DNSSEC. And finally, one of the other aspects that we like about this is it still maintains independence within the hierarchy, such that if you do say, oh, I want you to talk to this, this name server that doesn't know how to do tigers, that name server can still send you back to a turtle if that's, what makes sense in the incremental deployment of the feature. So as I mentioned, this indirection is based kind of like Service B's, the service binding record is called Service B, is based like its alias mode. Essentially, a special flag indicates that, oh, all of the other information you need to pursue this delegation is over at this other name that gets resolved. And then at that name, you can see in this particular example that there is a DS record, that's the delegation signer record, that is used to maintain the DNSSEC authority chain of trust. And so this would permit operators to still, resolvers that are using this mechanism would still be able to understand that, oh, now I'm using the operator's key to verify everything in the zone, and it all works out pretty well. One of the other things that you may have noticed coming out of the IETF, because it has been the subject of some controversy, is that we have several other transports now on which DNS is being offered. DNS-over-HTTPS, DNS-over-TLS, and DNS-over-QUIC have all been proposed through IETF standards track RFCs, but how do you find them? We don't have a great mechanism for doing that. Typically, the way that they're found is somebody has a compiled in list of, well, I know that if I want to talk to Cloud9 on their DOT server, that this is how I can talk to them. If I want to, talk to any given server using this particular protocol, I may have found it through network scanning or a hard-coded list, but there is no way to find that intrinsically through using the DNS. So one of the things that DELE could be used for is using application layer protocol negotiation to specify that, oh, when you're talking to this name server, I want you to please use this alternative. And significantly, you can also then divorce the streams as far as you can have one set of name servers, your traditional legacy UDP, TCP name servers doing the protocol, while having a special other set of name servers that is, more hardened, more whatever for doing encrypted DNS protocol. So with this record, we're looking at the possibility of being able to do all the things on the BHAG list. Significantly, this one example shows how one of the pain points that has existed in the DNS is that we're constrained by the existing wire format of DNS packets. Even when DNS-over-HTTPS and DNS-over-TLS and DNS-over-QUIC were all specified, they still use the traditional definition of what the actual DNS request packet and response packet look like inside. But now with this, we could imagine a situation in where we can get past some of the constraints of that format and use a whole new one. That's very much a future goal. It's not the immediate, there's no immediate plans for what DNS protocol version 2 would look like. But one of the significant things that we can imagine happening in that, and one of the reasons that the web people have been interested in this, is that there's a non-trivial community who have wanted the efficiencies of a DNS push mechanism. You can imagine that if you go to www.example.com and visit that web server, when you look at that name, the provider can go, you know what, since you looked up that name, I'm pretty sure you're going to want our images website also. So by the way, our images is actually hosted over on images.example.net. It's not our domain, but here I am pushing you all the information you need, not only to be able to identify that site, but to cryptographically verify that the address that I'm giving you is the legitimate address. So that's one of the exciting possibilities that we're looking forward to there. Why am I bringing it to you? If it's only just a proposal and it's not out yet, well, many of you, NANOG and the operations community and the standards community have often been at kind of loggerheads where the standards community is sometimes seen as a little too ivory tower, a little too academic on, well, we really think that this is the way the network should work. And then the operations community comes back and says, well, that's not really how it does work. And so one of the reasons I'm here is to search for your feedback, right? To the extent that this is going to be the right approach or not, we would like to hear what other people's requirements are, specifically how operators could make use of this in order to come up with the best protocol possible without just kind of foisting this out on the world from the standards community and saying, hey, here it is now, you got to live with it. We are actively seeking feedback on the draft that has been submitted. You can see at the GitHub, there are the additional drafts that talk about, well, here's now how you could use alternative application layers. And here is how you could use DNSSEC to do this operator functionality. But the core draft is out and is now currently being actively discussed in the DNSOP working group. We did have a BOF on it, which had some very useful feedback and discussion about whether this was really the right approach or not. And there will be, coming up at the IETF in Brisbane next month, there will be a Birds of a Feather session that specifically discusses it. One of the very promising things about this, some of you that have been around a long time have also heard many times, why don't we just have a DNS version 2, right? This is a very old conversation that's come up plenty of times throughout the 2000s at least, but it's never really gotten traction. One of the things that is really promising about this long list of names has people involved from pretty much all across every aspect of the DNS community. It has operators, it has developers, it has authoritative servers and recursive resolvers, it has registrants and registrars. So while I don't want to suggest that it's got 100% agreement, as we will get to in the next slide, there's been a lot of really positive energy to suggest that even while we have to work out a lot of the details, the energy is behind being able to achieve this in our lifetimes as a new technology deployed on the internet to kind of supplement what's been the success of the older technology. And as I mentioned before, it has been kind of socialized outside the DNS space already. Notably, when I first just started discussing it with web people and so on, it was to see whether anybody immediately was like, oh no, that's horrifying. And fortunately, we've gotten very, very little of the oh no, that's horrifying, and a lot of people saying, yeah, I could see how this would actually be really helpful. There is a lot of work to test and discuss it. As I mentioned earlier on in the slide, I'll jump past that first bullet point first, but when we first came up with it, we had a belief that resolvers would ignore a brand new record type in a delegation that they didn't understand, but we didn't really know. Fortunately, now we know, at least with all of the major resolvers, whether it be the public domain or open source resolver implementations or the major resolvers like Cloudflare and Google and Quad9, we know that this delegation format would work without having any changes to the legacy system in order to be able to continue resolving names in these domains. We don't know about all of them, and so we want to look into that little more. One of the things that the BOF has brought up, and as I mentioned Jeff Houston before, if you go looking at the APNIC website, you will see he also wrote a blog post questioning, is this going to really be the right approach? It's not determined, and very specifically, the exact format that I've shown you of deleg records has not been determined, but one of the biggest objections has been to the idea of adding even more complexity. This link, if you were to visit the slides online, you'll see the write-up of what the DNS camel is, if you hadn't heard that metaphor before. It's essentially that, we had this basic technology that was well described back in 1987 that we made a few changes to, but we keep making more and more changes to it. And is adding that complexity going to be, is the next thing going to be the thing that breaks the camel's back? Personally, I'm not overly fond of that metaphor because it does suggest that we just stop, just kind of put everything in stasis and leave it where we are. Like oftentimes, discussion of the DNS camel talks about worries about complexity without actually addressing how to deal with the camel. There is an additional question, though, that says, okay, well, if we accept that this is solving a set of problems and we could use a little bit more complexity to address this set of problems, then the question becomes, well, is this complexity the right complexity? And so that's, again, one of the things that I'm inviting the Nanon community to comment on, to identify ways that it, could work for them, or ways, that it might be made even better. And then there are a couple of other things that we don't have to go into details on, but it shows you examples of the type of bike shedding that, goes on in the discussion. For example, like, well, if you want to use deleg, but you really want to just talk to another turtle without any of the DNSSEC indirection and so on, should that be explicit, or should the record just, like kind of a bare, unadorned record indicate that, well, now you just assume the old style? And so that type of thing, are there particular conditions where if a resolver doesn't even signify that it understands eDNS, should it be considered modern enough to even get back a deleg record, and so on? So more testing has to go in on that. I also am interested personally in the idea, many of you may be familiar with registrars that take forever to implement any new features. And so I like the idea of, well, if I'm registered in one of those domains, but really want to have a sideways delegation that says, I'd prefer that if you would switch to talking to me quick on these name servers, should there be a way to do that? Right now, there's not. This is something that can be pursued after the initial protocol is worked its way through channels. So that was essentially what I come to talk about. I see we have another 10 minutes or so. So to the extent that you have any questions about this, I see Mr. Houston is coming to the microphone.
Hi Dave, Jeff Houston, and thank you for the talk. I must admit, applaud the idea that you said there of we understand that not everyone's going to understand deleg in the first instance, whatever it gets called. So we're going to put it alongside existing name server delegation records. So there's some NS records and let's call it a deleg record. Now, there's a real issue out there about aliasing name servers because the entire web content industry actually relies on lifting that name out of where it came from and dropping it into the service provider's namespace. And then they can control that name without any other referral. They can map it to geographies, they can dynamically translate. Great. And for the DNS, this sounds amazing. Now, I've got these NS records that I can't alias that are sitting alongside. So I use the awesome power of deleg and I alias it into Jeff's service hosting and it aliases 3 times and gets where I want. What do you do with the legacy NS? And if you lose compatibility, have you driven a forked path in the DNS that you can't get out of? You know, what's the answer here? I'm kind of stuck on that a bit.
Right. We're actively discussing it, as you've probably seen on the list, because it is somewhat like the IPv4 and IPv6 situation, and the very talk that you gave just yesterday about, well, we made IPv6 so kind of resilient with IPv4 fallback that it has really kind of slowed the progression of IPv6, because if you've got IPv4 working, why bother, right? And so there are different aspects of this. One is, even though people have talked about, well, what if you get into a situation where you have deleg records and then no NS records, right? Well, then I assume that you don't want any legacy resolvers resolving your domain name, right? That's the signal that provides. But then people argue back and forth about, well, if you have deleg and both NS, should you fall back to NS? I personally think yes, because if a legacy resolver could get that answer, I think your modern resolver should be able to get the same answer it did. But Jeff's giving me this quizzical look because it is a topic of discussion, people trying to understand like what a resolver operator might want to provide versus what the authority is trying to signify. One of the things with extensibility is we could come up with a mechanism that says, to the extent that we're signaling something that says, if this fails, please don't fall back. You can picture situations in both cases, like say you have a resolver that promises that everything is going to be over encrypted channels, right? And so maybe it stops its fallback when it says, well, I can't do DNS-over-QUIC. So this is the type of discussion that is going on, is going to be more in the BOF, is happening on the mailing lists. I forgot to mention, because these slides were submitted only recently, a separate mailing list named DD for delegated DNS has been created at the IETF, which is also where a large part of the conversation is happening now. Sorry, Jeff, to just sidetrack on that. For those of you familiar with my personal domain, dd.org, entirely coincidental. But that is, NS is likely to stay around for the rest of our lifetimes, in the same way that IPv4 is likely to stay around for the rest of our lifetimes.
So I've got this alias, and I've gone into Jeff's DNS factory, and I'm busy doing all kinds of stuff with that alias name. And I've got this legacy NS record over there in the authoritative point, and somehow I would like to get someone using legacy to get to the right resolution answer, which is machinery.
Right.
So the only thing I can think of right now is no more glue records in legacy. I just offer you the name and go, right, translating that name is going to be so much fun. Let's grind this. All of a sudden, I've made one of the key aspects of the way the DNS works, which is fast, efficient delegation. The glue records just come straight at you. Bang, I know where the next query goes. Into, no, you don't. Let me just call a halt to everything here because I'm going to give you a new problem, which is actually a harder problem than solving the deleg aliases, because now I've got missing glue and I'm into another world of hurt. This is kind of this issue about when I slide in a new transition, a new technology, and I'm trying to be compatible with what's around, because not everyone's going to do it at the same time. How much penalty do I place on legacy in order to create a benefit for new?
Right.
And where I see it going with Deleg is the legacy folk are going to have a bit of a burden if the one thing that really works, I think, for the providers, aliasing,
Right.
imposes this massive tax on legacy. And I think that's going to be the industry discussion about how much implicit overhead is a Deleg-like system going to actually impose.
Right. I very much agree on that. The one thing, I kind of buried it a little in there. I happen to think that this DNS push mechanism, personal opinion, this is not shared by all the I don't know. Maybe they share this, but I think
love DNS push.
Right. I think DNS push will be one of those things that drives interest. Like one of the other things I'll mention just on the history of DNS protocols in the application layer is I was co-chair of the DNS-over-HTTPS working group. I, as co-chair, was surprised at how many people were hungry for something like that and immediately jumped on implementing it, right?
Yeah.
And so I think there are killer features, of which DNS push could be one, that would help drive adoption of this, because it says, I'm going to make my CDN more efficient. I'm going to make my network more efficient if I can give DNS push to you.
And I'm going to ask the question, and you're not. And the privacy implications are brilliant,
Right.
because all of a sudden the client isn't doing a thing.
Right.
And it's the other side that's giving you alternatives, and the clients never pop their head above the parapet. But I'll sit down now. So I don't think Deleg's going to be easy. Right. And I suspect a lot of the discussion is not about the technicalities. I think that's actually quite easy. It's actually about the balance of the workload in trying to be backward compatible.
Right.
Thank you.
Well, and I will address on that one, not only the backward compatibility, but several people have asked, what's the benefit to an authoritative server? Why should I go ahead and, worry about implementing this one additional thing? And I think that the answer is going to be there. It's because your customers are saying, we really want to have an ability to get to alternative transports without having to make sure we got added to Firefox's list. So,
thank you.
Yeah. More questions? Any from online? Okay. Thank you very much, everybody.